All right guys, so welcome to the installation video of our 1947 Chambersburg 750 high frame power hammer. By the way, we are going to do a cost breakdown of everything involved, cost associated with installing this power hammer. So be sure to stay tuned to later in the video where we break down exactly how much this machine cost us. All right, so we're gonna start this video with a little bit of history on the machine, where it came from, where it's been, and how I got it. And then we will jump into the actual installation. So if you want to skip ahead to the action, skip ahead to this position in the video, and that'll go right into the action. But if you're interested in some history, let's dive in. So this power hammer came with a bunch of original paperwork, screenshots of the original work orders, and also orders on maintenance that the hammers had throughout the years. So it's really cool to have some of this paperwork. We've got the original shop order here from Seaboard Airline Railway in Charlotte, North Carolina. They ordered the hammer directly from Chambersburg in October of 1946 with a delivery date of February of 1947. This hammer was a new design for Chambersburg. They had an older version and then a newer version, and this work order is for the new design, which is to be operated with air. So this hammer was originally purchased and built by Chambersburg to run on air, not on steam. The previous design was of course on steam because these were steam-driven power hammers. But ours was some of the first ones to come out of the production line that were actually built for compressed air, which is how we run it today. So I'm not sure how long the power hammer was at Seaboard Airline Railway in Charlotte, North Carolina, but I do have a list of the customers or the people who bought the hammer after it left that factory. So after that, it went to a company called Beck's Body Shop, where it's a little bit unsure as to whether or not the hammer actually ran. There is no date associated with that, but a company by the name of Beck's Body Shop owned the hammer for a period of time before it went to the person who put it into storage long-term. Again, don't have any real dates on that, but the person who put it into storage is where Chris Cash bought it from. And from our best guess, it looks like the hammer had been out of production for at least about 50 years, potentially even longer, in storage at this storage place. So it's very exciting for us to be able to install a piece of equipment like this and kind of rescue it from its abandoned place, out of use for so many decades. This sort of machine, we're told that there's only a handful of people, like you can count on one hand how many people in the modern day and age have actually set up and installed one of these hammers. There's a good handful of them out there, but the majority of them are already in place and set up, and those people who are running them never installed them. They were already there. So to the best of our knowledge, one handful of people have ever actually installed one of these hammers, which is a really cool, unique place for us to be. It presents a lot of challenges because there's not a lot of people you can call about this sort of thing. Luckily, we were also able to get a hold of the original blueprint design for the hammer's foundation. The hammer's foundation is critical to the operation of this machine. There is a lot of energy being created and transferred from the machine into the ground, and a machine like this requires a pretty beefy foundation, and one designed very specifically for its use case. You can't just put a block of concrete into the ground and set this machine on it. It generates enough energy that the energy would transfer back up into the hammer and potentially crack the frame of the hammer. So you'll see we utilize concrete and timber in several different areas throughout the foundation, specifically for avoiding that problem. We are following to the letter the blueprints for the hammer's foundation spec'd out by Chambersburg back in 1947. I actually went a little bit above and beefed up a couple of small areas just for ease of measuring timbers and getting timber sizes, but there was no compromise on any part of this foundation. All right, so now let's start kind of rolling into the story of this power hammer. It took us 14 months to build the foundation and install this power hammer. Now, this started last year in 2024, July 29th, the hammer was delivered to our shop by Chris Cash. Mount Phillip Metalworks, this is the guy we bought the hammer from. Chris had set up this power hammer and run it a little bit at his shop under limited air supply just to test its function. He replaced a couple of things. He put a couple of new control arms on the valves, stuff like that, just to get it to a point where he could test it and make sure everything was functioning correctly. He also did some work up on the air cushion and some of the valving, just getting things kind of tuned up. But on the 29th of July, the hammer was delivered to our shop. After that, it took us through sometime in September for us to have time to actually start working on the foundation. We had the hammer here sitting for a few months while we kind of figured out our strategy, started ordering all the timber from the mill, getting our rentals, because we had to rent some equipment to do this. So we got the rentals all set up. And then on September 4th, we started cutting up the floor for the foundation, slicing a giant square out. Off the top of my head, I can't remember exactly how large it was. We'll put that up on the screen here. But a very large square of concrete came up, which is always fun to do. So the foundation of this hammer is about 12 feet deep, just a little over. And here at our shop, we actually have a nice river that runs out back. And we're up a ways from the river, but at the 12-foot mark, we did start hitting the water table just slightly. And that, of course, as you can see, added a little bit of fun when it came to pouring the concrete in, because it looked like we were pouring it into a ton of water. There wasn't actually that much water at the bottom. The water just rises with the concrete. So on September 9th, 2024, we officially poured all of our base concrete. So this is 5 feet of concrete that covers the entire floor of the bottom of the foundation. This is kind of our base to start from, and we needed all that in first, and we had to get a pretty good cure on it before we could start putting in our timber and then the anvil on top of that. So after pouring all that 5 foot of base, we let it sit for a little while. In the meantime, about mid-September, we started cutting up timber for going directly under the anvil. So the blueprint for this hammer foundation spec'd that we needed approximately 3 feet of timber underneath the anvil. Now, as you see from these clips, the anvil is really big. There's a lot of mass there. It weighs about 12,000 pounds by itself. And it is, of course, 2 pieces. This is not part of the hammer frame. And so the anvil of this hammer needed to be supported all on its own on about 3 feet of timber. And so we cut up some 12 by 12 timbers, bolted them all together, both directions, and lowered them into the foundation hole one level at a time, creating about a 3 foot tall timber base for the anvil to sit directly on. So on September 26, 2024, it was finally time to put in the first piece of the hammer, and that was to put this anvil on top of that wood base at the bottom of the hole. We had Hampton's Towing, which is a local towing company to us. They came out and brought one of their wreckers that they could actually fit into the building, and they lowered it in with that. We tried to do it with the forklift. The forklift can pick this anvil up from the bottom, but it can't be slung. It can't sling it from overhead, which is what we needed to lower it into this hole. Our forklift just didn't quite have the capacity to do that, so we brought out a wrecker truck to come out and do the job for us, and it worked well. It was right at the limit for this truck. I mean, it lifted up the front end a couple of times, but we got it done. And this is where things kind of grind to a halt. September 27th, 2024, our area was hit by Hurricane Helene, which ripped through here very unexpectedly, caused huge amounts of damage to our area. In fact, some of our employees, it took several weeks for us to get back to the shop and kind of get things back up and running. Luckily, our shop was undamaged. It did not take any the flooding of any sort to the building itself. We did have some trees fall on the parking lot, but really wasn't that big a deal. The only flooding we had was in the foundation of this power hammer hole. So we already had 5 foot of concrete in the hole. We had 3 feet of timber directly under where the anvil would be, and with the anvil sitting on top of that timber. And then the flooding came up from the ground level and flooded that hole, and we ended up having to pump out all of that water and redo all our work on the timbers. The timbers were saturated and soaked. And so that was a major setback on the foundation of this hammer, because we had to spend all that time kind of fixing what we had already done. So fast forward to May 9th, 2025, and momentum on the hammer build picks right back up, and we really get going on the rest of what has to happen on this foundation. So we started with that 5 foot of concrete on the bottom, and then we have the wood foundation with the anvil. But on either side of the anvil and wood base, we have to bring the level of concrete up to a much higher point so that we can then start building the timber for the base of the frame. So we framed out the base and anvil to keep the concrete off of it. We wanted to be able to pour front and back and still be able to get the anvil and base out of this hole if we ever needed to pull it out for any reason to make adjustments or fix something. So we built out around that wood base and anvil to protect it from the concrete, and then we poured front and back to bring it up to, I think it was approximately another 3.5, 4 feet of concrete. I can't remember right off the top of my head, but we needed to bring it up to a certain level to start the timber work for the base. Once that concrete was set, we started yet again on cutting up a whole bunch of timber. So this timber, I wanted to specify, does come from a local sawmill. That timber comes from here in the high country. It is oak timber, white oak. It has been cured, and it is very, very large, very, very heavy. As you can see, we move this stuff around with the forklift. So we started cutting and laying these timbers, starting with some parallel beams that go parallel with the anvil on both the front and back concrete pads to bring it up approximately 6 inches. And then we lay across those, we lay all of our top timbers. And these top timbers are what the hammer frame sits on. These are all tied through those very long all thread bolts to the very bottom concrete slab at the bottom of the hole. Those top timbers are all tied to that. And so then we tighten everything down. It compresses those timbers into that concrete that's all the way at the bottom. And so it creates a very, very stable foundation for the frame of the hammer to be bolted to. Prior to standing up the hammer, we did pocket out the timbers so that we had a nice seat area for the hammer to recess into. It does have some castings on the bottom of the hammer that need to recess into the wood floor a little bit. So I spent a bunch of time with a routering that out. And that's not fun. I'm a steel guy. I don't like working with wood, and routers make a mess. But we got it done, and it was time to start standing up the hammer. So this was a very, very nerve-wracking part of the process, obviously. Step one was figuring out how we were going to literally stand it up. The hammer has to be stood up one way. It has to be stood up, laying on its side, from back to front, stood up over the anvil. The anvil slots into a hole in the base of the frame, and that anvil sticks up several inches above floor level. And so getting that to line up properly was going to be difficult. When we planned all this out, we realized we were going to have to bring in a lull or a telehandler machine to be able to extend over the hammer and grab it from the top of the hammer to do the stand up in order to be able to get it the way we needed to position. But a telehandler rated to lift that much weight and extend that far out was a big machine. And so I was looking at the rentals at our local rental place and realized that the telehandler was going to be too big to fit through the center wall doorway of our shop. Our shop is split down the middle with a wall, and there's a big opening where we drive the forklifts and stuff through to go through to either side, but the hole was not big enough for the width of the telehandler. And so we ended up having to cut open that wall an additional couple of feet in order to get the telehandler to fit through the doorway. So step one, telehandler is in the building. Step two was doing the stand-up. And it only took like 2 hours of actual time to stand it up, but it felt like it took all day long. We went very slowly. We had a forklift on the front end up against the hammer to help lift it initially, and then to just be there as a safeguard to protect it if something went wrong and the hammer started to, fell back forward. Lots of little small adjustments here and there and going really slow. Overall, it went pretty well. We got the hammer, dropped it over, set it in place, and then we were able to make our final adjustments to the frame by just scooting the frame around a little bit in its pocket. So a few days later, on June 28th, we started working on the air system. As I mentioned earlier in this video, this is a air power hammer. It is run on compressed air, and we bought a 50 horsepower screw compressor to run this hammer. And we needed to hook up an air system in order to store air and pipe it to this hammer. The hammer is in the middle of the forging bay. It's out in the middle of the shop. It's not up against a wall. And so we had to run air up from the hammer to the ceiling and then across the ceiling, all the way across the shop to an exterior wall to come down where it would go out the building to reservoir tanks. Now, I know a lot of you guys saw some of our reels on Instagram or commenting, it's a screw compressor. It's meant to be run nonstop. You don't need air storage tanks. This hammer consumes so much air very quickly that we wanted to make sure we had reservoir space if it was necessary. We bought the compressor specifically for the power hammer and nothing else. And so that was all that was going to be on this compressor. So we opted to run it out to two big old converted propane tanks that I converted to air with drains on them. And that was another reason for the air tanks, is because they act as a bit of a hold for the water. As the water accumulates all that moisture in those lines, each of those tanks has drains on them that can drain all the water out. We do have an air dryer that goes with this air compressor that we will be hooking up to the system as well. But remember, these hammers were built to run on steam and compressed air. I mean, most of it hasn't changed from when it was run on steam. And so it's not a more modern machine that requires super clean, pure air. This is an old machine that will run on pretty much anything air related. So we do have a good oil system that we'll talk about later to make sure everything stays oiled. But we have multiple drop ports and moisture points where we can pull the moisture off the air throughout the system. So threading pipe, lifting up all this Schedule 40 2-inch pipe into the ceiling rafters was a lot of work. I'd never personally threaded pipe before, but we did rent a pipe threader, and that was honestly a lot of fun. I love threading pipe. That was super cool, very satisfying. And we had a lot of pipe to do. I don't have the measurement off the top of my head, but I'll put it up here as to how many feet of pipe we had to install. But it is Schedule 40 2-inch pipe, because this hammer has a 2-inch inlet and a 3-inch outlet. So anyway, piping went up, and once we were pretty much done with pipe, we were ready to move on to the electrical side of things. Now this is where we hit another time snag. The 50 horse compressor is a 3-phase machine, along with some of the other machines we're putting in this shop. And this stainless production line, which is why this hammer is being installed, is for the stainless production line. It needed more 3-phase power. And we knew this going in way ahead in advance. And we scheduled our commercial electricians to come out and install a new 3-phase panel and run new lines to all this new equipment. And the air compressor was one of those items. The hang up came in two factors. One, when they came out to get started, they called the power company and said, hey, we're gonna need you to run another line from the pole down here to our new 3-phase system. And the power company said, you're already at max capacity on your transformers on the pole. And so you have to upgrade those and upsize all the lines to your shop before we will put in anything new. So that was a really quick and fast $30,000 hello, right in the middle of us trying to get all the systems set up and running. You know, we had a lot of stuff waiting in the pipe for this hammer to be up and running. And to get hit with that was kind of a blow. Not only was it expensive, and they required full payment up front before they would even start. We had to wait on the power company to come out and do transformers. And I think most of you can relate. Power companies tend to take their time. The other slowdown was the 3-phase components for the actual panel. Those had to be custom built out of a company in Texas. And they got way behind on some components, and due to some of the tariffs between Mexico and the US, some of those components took a lot longer to come in than they were supposed to. And so a lot of electrical holdups for quite some time, I think almost 2 months worth of hang up on just getting the electrical set up. So it finally got it all sorted, and we were ready to go. They hooked up power to the air compressor to run the power hammer, and then we were pretty much ready to turn this baby on. Before we turned the hammer on, kind of during the period where we were waiting for the electricians to finish up, we decided it was time to paint the power hammer. I kind of didn't really like the color it was. It was this weird off grayish green color, very banged up, old rusty spots all over it. And I do like a good used original looking machine. That was not the original paint. That was a paint that was put on it sometime during its life. It was not original. You could see paint color from underneath it, or that may have been the original. I don't even know what color it was. Obviously pictures from back then are in black and white, so you don't know what color it was. But it needed a paint job. And so Waylon and I spent a day, I don't know, Waylon, how long did it take us? I mean, yeah, it took us a handful of hours. We cleaned the machine down real well, got it all degreased, cleaned, brushed down. and ready for paint. We painted it with a black epoxy and then did the really cool gold lettering on all the stamped lettering on the side of the casting of the frame of the hammer. Anywhere there were letters or numbers, we did it in gold, and it just stands off really well and was a really, really cool industrial look. That really changed the whole landscape of how the hammer looked, and we were really excited for how it came out. So now it's time to fire up this baby. So the guy I bought the hammer from, Chris Cash, he really wanted to see this hammer up and running. So he had told us, hey, when you are ready to fire it, call me, I'm gonna come down. So he drove down before we ever opened up the hammer air supply and turned it on. Partly because we wanted him to be here for that. So I didn't really know the valve arrangement on this hammer and where it was positioned currently. There's two levers on the right-hand side of the hammer. One controls the opening and closing of the valve to send air into the cylinder, and one controls the ram height, where that ram is positioned before you start cycling the ram. I didn't know where they were in their process. There's no markings or anything. It's not a open and closed. It's a range on those levers. And I didn't want to send air to the hammer with those levers in the wrong position and the thing just start going to town. Just wah-da-da-da-da-da. Didn't want that to be the case. And so I wanted to wait for Chris Cash, who has used the hammer before. And he came down and we started working on it. And then we ran into a few issues. First off, we put all the wood shims in, and we shimmed the anvil, so the anvil was in place and the dies were aligned, but the hammer was running very inconsistently. We were not able to really control it. We'd give it a little bit of air and it would start going off like crazy, and almost like a runaway diesel, it would just kind of run away on you, and you have to kind of shut the whole system down, which was a little scary because we couldn't figure out exactly what was going wrong. We were making adjustments. There's a turnbuckle on the left-hand side that adjusts your ram height adjustment lever, and we were making all sorts of adjustments and trying different levels of air supply, trying to figure out what was going on with the hammer. The air system worked phenomenally. That all worked great. The control on the hammer was an issue, and took us, I don't know, what was it, 14-hour day of Chris Cash and I just sitting here working on it, trying to figure out what was going on. And turns out it was a very small, little, easy thing that we overlooked. And that small, easy thing was the stuffing box. So the stuffing box is a steel block that is clamped around the shaft of the cylinder ram, and it is bolted up around that cylinder rod and compresses several sets of compression gaskets that seal the air from escaping around that ramrod as it's cycling up and down. It was leaking air, and we knew it was leaking air right from the get-go, and we actually were utilizing that to our advantage by dumping oil into the system and then cycling the hammer and letting all that oil run through the hammer and then kind of spit and spurt out of that stuffing box and down the ram of the hammer to just clean the system out. I ran, I don't know how many quarts of oil through it, just to flush all that until the oil started running out clean, to make sure there was no gunk or buildup in there. Well, it didn't really seem like that much air was actually leaking from around it, but it was enough to affect how the hammer ran entirely. And we didn't find that to the very end. And when we noticed that if we cut the air supply level down a lot, to the point where it was not enough pressure to actually leak past that stuffing box, that the hammer control suddenly worked, and we were able to control the hammer properly, but at very little power because we had the air supply so low. So that's what triggered it in my head, and I realized that stuffing box needed to be addressed and that was causing all of our issues. So we unbolted the stuffing box, and the screws holding it up were all banged up and bent and old, so we cut those out and we replaced those with new ones. The actual packing gasket material around the ram cylinder was in great shape. I pulled a couple out because I thought those were going to have to be replaced, but they looked almost brand new. And I just realized that stuffing box just wasn't up in there tight enough. It was actually kind of sitting there a little bit loose. And so after replacing the hardware, we just bolted it back up and we cinched it down properly, and the leaking completely went away. And the hammer control was all back. It was perfect. It was easy to set the ram height exactly where you want it to. The ram stopped at whatever height you set it at. And then when you gave it gas on the treadle, it would start cycling like it should. So Took a very long time to figure that out, but glad we did. The hammer runs absolutely beautifully now. And that kind of gets us into some of the more finer touch-up things that we did to the hammer. So let's actually get up over here and go over to the hammer, and I'll show you some of the last few things that we did to get this beast up and running. So we needed to put a treadle on this hammer. It did not come with one. You can control the hammer using these levers manually, but that's a two-man job. One to control here, and then one to hold the steel in the hammer. We wanted to set it up so that one guy could walk up to the hammer and forge on it. So we needed a treadle. There's locations here in the casting for you to tap and drill into to mount a treadle to it. So that's where we started. We tapped out the back ones, and then we just built linkages that we needed in order to create a treadle. The treadle's not perfect. Bending tube is not our forte. We needed to turn this tube all the way around, of course. And we didn't want to use solid bar because solid bar would be really, really heavy. And we would have to do different adjustments on the linkage in order to run a treadle that was that heavy. So trying to keep everything light, we used tube, filled it full of sand, and then forged it to create it round. And built all the linkages from scratch. I mean, nothing here was purchased as far as the linkage goes. You have to make everything in-house. That's why you have a mill and a lathe. So we turned all these linkages and hooked everything up. Everything's got turnbuckles or adjustments on them so that we could adjust it as we go to get it tuned in and dialed in to right where we wanted it. Something over here before we move on that we are going to update down the road is this bar right here. This is white bar, and it is for clamping your lever here, which sets the ram height. It won't stay up on its own. It falls all the way to closed with the ram down. But we wanted to be able to bolt this in position. And normally on this hammer, there's this kind of half moon crescent shaped ring with notches in it. And this lever, which is also not factory, but the factory lever had kind of a little squeeze gun ratchet system that you could set the height on this half moon to whatever setting you wanted it at. And that stuff was long since lost through the years. It is not on the hammer anymore. And so in its place, we've simply got a bar here and a bar here. And when the guys get the hammer up, or get the ram up to whatever height they want, they need to just clamp it in position like that. And normally they're never changing this anyway. They raise it up, they set it, and then that stays that way for the whole day. So it's fine for now, but I do want to design and water jet out one of the proper original lever ratchet rings and build an original setup here so that it's true to the era of the hammer, because this is definitely not, but it works for now. Moving on, we'll go to the other side of the hammer. Let's talk about the oiler. This hammer also did not come with the oiler. The original oiler was mounted right here, and it was a mechanical oiler that had a little pump arm that you pushed, and as you pushed on that, it pumped oil up the lines. And that arm would have been attached to the linkage right here to allow, whenever you're pushing on the treadle, this operates up and down in a rocking motion, and it would activate the oiler, which would then pump oil up into the valves. There's only one location on this hammer that needs constant oiling, and it's right there. But I can't find an oiler to go here. They are like non-existent. I'm going to keep searching for one, and eventually I'm going to find one to do an original oiler on this hammer. But in the meantime, we installed a little manual one. So this is just a standard oiler like you see on the side of like a lathe or a mill or something. You operate it by pulling the lever. It pushes oil up this line and drops it up into the intake port for the hammer's air supply. Obviously, there's air pressure in that cylinder, and so there's pressure into this air line, and so we had to put in a check valve so that it doesn't blow pressure back into our actual oiler reservoir and make a big mess. So those are just a few of the things that were kind of last minute that we had to do to get the hammer in tip-top operational running condition. Other than that, I mean, we've been using this hammer for 2 weeks now in production, and it is a beast, as you can see from these forging clips. It moves steel incredibly fast. The 750-pound ram is a monster. It's like forging with a Honda Civic, baby. I mean, it's a lot of energy. And as the machine is settled, we got to keep tightening up the mount bolts that mount the hammer to the timber, and the bolts anchoring all the top timber to the concrete. So we keep snugging those up as it starts settling. We'll probably be making those adjustments and tune up as the hammer is operated over the next probably year or so. We'll continue to monitor those and make sure everything stays tightened and adjusted properly. But let's move on into what it cost us to set up this hammer. All right, so we're here in the office. I have a spreadsheet of every cost associated with building this hammer base foundation and installing the hammer. This is to kind of give you guys a comprehensive overview and understanding of the costs involved in taking on a project like this. This was not a cheap endeavor by any means, and lots of costs all over the place, and I did my best to catalog them all as we did it. So throughout the entire process, I cataloged on this spreadsheet exactly what we were paying for all these things, and it was a very detailed sheet, and I've kind of compacted it into more price categories. That way we're not going through line item of this bolt and that shim and, you know, weird little tiny washers. I've kind of put them all into their category. So let's jump into this. Starting off here at the top, we've got the hammer itself. I got this hammer for $10,000. That is incredibly cheap when you look at the grand scheme of hammers of this size and caliber. Part of the reason I got it so cheap is the seller, Chris Cash, knew exactly what it was going to cost to install something like this. I mean, it's not a cheap endeavor. He gave me an amazing deal on it, and we'll be forever grateful for that. But $10,000 on the hammer, that included 80 feet of 2-inch pipe for the airlines and one 500-gallon air tank. We then have the freight shipping costs, which was $1,250 to move the hammer from Chris Cash's shop down to us here in North Carolina. We then have the air compressor, which is the 50-horse screw compressor purchased from Yoder Machinery. I bought this air compressor on a bundle deal with a bunch of other machines, so I was able to get it for $12,000, but it's more like a $15,000 to $16,000, $17,000 air compressor. So I got a deal on this as well because I was buying a bunch of different machines and struck a deal with Yoder. Next is some of the equipment. We got the floor saw and pavement breaker. We had to rent that in order to start cutting up the foundation. That was $600 for a 2-day rental on both. We've then got our concrete. Total concrete was $7,750. That is for a total of 45 cubic yards, which is about 90 tons of concrete. That is the first 5 feet in the bottom of the hole, and then the 2 upper segments that were poured later on. Now, timber. We used 23 white oak timbers of varying sizes. The ones under the Anvil were 12 by 12, and then a couple of other sizes to do the top portion. All in $5,750. Rebar and anchor hardware. This is all the rebar cage at the bottom of the pit for all the concrete pours. Then that's also all the 1-inch all thread for holding the beams together, the bolted beams together, and the ones that ran vertically up from the concrete all the way up to the top where the hammer is bolted on. All that anchor hardware and rebar is about $1,500. We then had the telehandler rental. That was for, of course, lifting the hammer and putting it into place. That was $1,700, $1,750. That's a 16,000-pound telehandler plus delivery and pickup charges, or just a rental for 1 day. Excavator rental, that was for digging out the hole, $1,300. And I believe we had the excavator for 2 days, if I'm not mistaken. I don't actually have it listed on this sheet. Moving down to air piping and threader rental. So we had a whole bunch of air pipe that came with the hammer, but I had to buy a bunch of different fittings, shut-off valves, 90 degrees, 45s, all kinds of different smaller components I had to buy. And then we had to rent the pipe threader for a couple of days. That was $1,000. Air tanks. So we had the one 500-gallon air tank that came with the hammer, and I purchased another tank for $1,000 off Facebook Marketplace, another 250-gallon tank to add to the air system, just so I had that extra level of storage and somewhere to trap the water. Treadle and oilers next. That's kind of one of the last things here. $700 just to buy all the material to build the treadle, build all the linkages. We had to buy some different bits and stuff for our mills and stuff to make these parts. And then oiler actually wasn't cheap either. Those things are a little pricey. And then all the lines to hook it up, so about $700 worth there. One of the biggest costs is of course the electrical work and new transformers. We spent $35,000 on transformers and the new 3-phase panel for the shop. Now, something to note here, this was not just for the power hammer. Well, for the air compressor. The power was needed to run the air compressor, but it also is set up to run a mill and a couple of other smaller machines. And so it wasn't, all this cost can't be 100% associated with the power hammer specifically, but it is the majority of it, and enough to just go ahead and line item that $35,000. You would have to have that much air supply, and you'd have to have an air compressor of that size in order to run this hammer, so that cost is in there. So that gives us a subtotal of $79,600. That is before any sort of labor. Now, if I was able to do this all by myself, that's one thing. But I couldn't. And I have employees here at Baker Forge who helped along the way pretty much every step. I did a lot of the work myself when I could, but most of the tasks require multiple people. As you saw from all the footage, I mean, there was almost always Cole or Jay or somebody was there helping work on it. So trying to calculate the time was really difficult. And I know it's more time than this, but I priced it out at 2 guys, 40 hours a week for 8 weeks at $35 an hour, which is kind of just a ballpark price on an hourly rate for a guy. But that amount of time adds up into about $22,400 worth of paid labor that I paid out for the installation work to the guys here at the shop. So that's a little bit of a rough number. I think it's really low, but I didn't want to put a whole bunch in here and just blow this chart up with an outrageous number. This was some calculations and trying to get as close as we could on how much time it actually took to install, not including my time. So this labor number, $22,400, does not include my time. This is paid labor only for other guys. That leaves us at a grand total of $102,000 to install the Chambersburg high frame power hammer. That is a lot for a power hammer. I mean, in the grand scheme of things, with the really massive hammers, yes, the prices can go even much higher than this, but that just goes to show I paid $10,000 for the hammer, and I, at the end, was $100 grand into it. It's worth it for us. It would not be worth it for a lot of people to do that. It's worth it for us here at Baker Forge because we make steel. We are going to reap the benefits of this machine, and it is going to pay itself back over time, and is actually going to do it pretty quickly based on our calculations. So it's worth it for us to spend that installing a power hammer. Anyway, just wanted to give you guys a breakdown of what all the costs were, what everything was associated with, and what it looks like to price-wise install a hammer of this size. So that's the breakdown on the numbers. All right, guys, so that is a wrap. That's the installation of the Chambersburg high frame 750-pound ram. It was a ton of work. It was a ton of fun. It took way longer than I anticipated, but this is the quintessential piece of our stainless Damascus production forging line. So it is rocking and rolling. We're 2 weeks in and it's working phenomenally. No issues. Love the hammer. Would do it again in a heartbeat, and we're excited for everything we can forge on this for the years to come. So thank you guys for following along with this video. I know it was a little bit lengthy. I love going deep on this sort of stuff. So thank you for sticking it out and supporting us. So you can always check us out on Instagram, Baker Forge, and Tool on the website as well. Give us a like, drop a comment down below if you like the video. Thanks, guys.